Now that we have seen how to use the script context inside Plutus scripts, how to deal with time and how to write parameterized contracts, I want to talk a bit about off-chain code. So on-chain code is something like validators. It's Plutus scripts that are executed during validation. And off-chain code is interaction with the blockchain. So on the one hand, you want to query the blockchain to see what UTXOs are there. And on the other hand, you want to construct and submit transactions. Last week, I showed you how to do these things using the Cardano CLI, which is a very nice tool, but also requires quite a lot of manual labor to make it work. Today, I want to demonstrate another tool called Lucid. And if you just Google Lucid Cardano, you will find it. And it's an NPM package. So you can use Lucid writing JavaScript or TypeScript code. And if you follow this link here, there are some basic examples. And further down, there's a link to the API documentation. Using Lucid, I wrote a little DApp to interact with the vesting contract we saw earlier. And in order to try it out, you should change into the Lucid folder in this week's code folder. And then first do npm install and then npm start. And that should open the DApp in your browser. I wrote it to work specifically with the Nami wallet. It would be easy to change it to also work with Eternal or other browser-based wallets. And if you run it for the first time, then probably your Nami wallet plugin will pop up and ask you whether you want to connect to the DApp. If everything works correctly, then you should see your public key hash here and your balance in test ADA here. So it's connected to the preview testnet in this case. I have two Nami accounts. This is now called Preview 1, and I also have another one called Preview. So in order to try the vesting, I want to make one of those two wallets the person that creates the vesting and the other one the beneficiary. So let's say this one, Preview 2, should be the beneficiary. I can click here to copy this pub key hash into the clipboard. Now let me change to the other wallet. So to Preview, we should see this change. Now it changed. So now we are connected to the other wallet. And here on the left-hand side, I can create vestings and I can claim vestings. And in order to create, I need the beneficiary, the public key hash of the beneficiary. So that should still be in my clipboard. That's this one. Now I can specify an amount in Loveless. Let's pick 1000 ADA. And I can pick a deadline. Let's just take something that lies 5 minutes in the future. And I click Vest. Now my Nami wallet pops up and asks me to sign. Also can see some details of the transaction. This is a link to Cardano Scan where I can look at the transaction. But at the moment, it probably won't be there yet. This table shows all the vestings that have been found on the blockchain. So the one we just created is now here, and we have the TX outref here, the beneficiary, the amount, and the deadline. We can check whether the link works. Not yet, so I have to wait a bit. And there it is. So it really was deployed to the testnet. Here we can particularly see the UTXOs. So we see that 1000 ADA were locked in this script address, and also some inline datum was attached. You can actually inspect it. So this is the beneficiary and this is the deadline. So now let's go back to the DApp and let me switch wallets. So I go to preview 2. Okay. And now we see that I am the beneficiary. So let's try to claim. All I need in order to claim is give the TX out ref of the UTXO I want to claim. So I copy that in the clipboard, press claim, and that transaction would give me the 1000 ADA. Let's try to sign. The problem, however, is the deadline has not yet been reached. So if I confirm, I get an error message. And if we read that, it basically says that we try to submit a transaction with an invalid validity interval. So at the moment, it's not possible to get to this UTXO. So I'll wait for 2 minutes or so. Now the deadline has passed. So let's try again. And now it seems to have worked. And after waiting a bit, the UTXO disappears from this list, and we also see our balance increasing. So it worked. Let us look at the code quickly. It's defined in index.js. So here I import Lucid. Then I define my vesting script. So in particular, I need this CBOR here, and I get that from our vesting.plutus that we created from inside the on-chain code with this save val function. So I just took this CBOR hex and pasted it here. Now we have the datum. We have to deal with datum, and the datum is this Haskell type vesting datum, but we need to convert it to JSON. Last week we saw how to do that, but Lucid also has a automatic way to do this. So you can define basically a schema for your type. So this is very similar to the Haskell data type. So I have two fields, beneficiary, deadline. Beneficiary is just a string and deadline is a big int. And then I can later use this scheme to convert back and forth to JSON, and then Lucid can deal with the JSON. This is just a UI thing that's not important. This is where I initialize Lucid and connect it to my Nami wallet. So the Nami wallet plugin is available as a global object window.cardano.nami. If you wanted to use another wallet, for example, Eternal, it would be window.cardano.eternal. I enable it, then I initialize Lucid, and there are lots of options, but I chose to use Blockfrost. And this is my personal key to connect to the preview network. So after this lecture, I'll remove that. So please, if you want to try it, create your own keys. You can do that for free. Specify I'm on the preview network. And then I link the Nami wallet that I initialized here with Lucid. So now Lucid is connected to the Nami wallet, and all activities that require a wallet will use the Nami wallet. This is a helper function to submit a transaction. So given a signed transaction, I can just call submit on it, and the return value will be the transaction ID, the transaction hash. So then I just log that in the console. And I also had this table with the links to Cardano scan. So this is happening here where I include this link into the table. Another helper function to sign and submit. So given an unsigned Lucid transaction, I can just call sign on it and then complete. And when this is executed, it will, in my case, because I hooked up the Nami wallet, it will pop up the Nami wallet and prompt me to sign. And then I call the function we just looked at to actually submit it. This is just error handling. This part is to display the public key hash belonging to the NAMI wallet. So the wallet has an address function, which gives me the address, or one address. In the case of NAMI, NAMI only uses one address. It's not an HD wallet. But Lucid can also handle, for example, Eternal, where you have an HD wallet with several addresses. Then on Lucid, there's a function called getAddressDetails that I can pass this address. And the address details in particular contain payment credential.hash. So this gives me the public key hash. This is in order to display the status line. So one part was the public key hash. I just explained that. Then I want to display the balance. So there's another function, lucid.wallet.getUTXOs, which gives me all the UTXOs in my wallet. And then I just have to extract the loveless from that. So this is an array of UTXOs. So I loop over them. And in each of those, there's an assets field. And in assets field is a loveless field. And I add up all the lovelesses. So for this, I ignore native tokens. They would also be contained in these assets here. We'll look at this later. This gets all the vesting UTXOs. And then the triple of public key hash and balance and the vesting UTXOs is what I call status. This is just UI stuff to build the tables. This as well. This is where I fill in the status. So this is nothing particular to Lucid. It's just HTML. This is more interesting. It's how I fetch the vesting UTXOs. I said earlier that when I talk about off-chain code, I'm talking about interaction with the blockchain, which has two parts, querying the blockchain and constructing and submitting transactions. So this is the querying part. I want to get the vesting UTXOs. So I have the address. This is actually done somewhere down here. So I earlier showed you the vesting script that I got with the CBOR hex. And then there's a Lucid utility validator to address that, given a script, gives me the script address. So this is the address of my vesting contract. And Lucid has a function UTXOs add, given an address, returns an array of all the UTXOs. Now, there's one important thing that I can't stress often enough on Cardano. Validation, in particular Plutus validation, Plutus validators, only happens when you try to spend a UTXO, not when you send something to an address. So we have these script addresses, in this example, the vesting script, and that is only executed. Validation of the script only happens when I try to spend a UTXO sitting at that address. But anybody can send anything at any time, anywhere on Cardano. So you can send arbitrary stuff to this address. But of course, I'm only interested in UTXOs that have the right type of datum. So datum of this vesting datum type with beneficiary and deadline. So what I'm doing here is I filter those out. So I look up all UTXOs at this address. Then there's a .datum field at the UTXO, but this is basically just JSON. So now I use the schema I defined earlier. So there's this data.from function that gets the datum and the schema I defined earlier and tries to convert that into the type of the schema that I defined earlier. So if there is a datum with the wrong type, or maybe a UTXO that doesn't even have a datum, then there would be an exception here, and I just don't do anything in that case. But if I can successfully convert it into this vesting datum type, then I know it's a UTXO that I can actually consider that might be a legitimate vesting UTXO. In that case, I just add it to my list. And on this list, I save UTXO itself, but also the converted datum so that I can later easily work with it. find UTXO is used for the claim functionality, where I want to redeem a specific vesting UTXO. So ref is the TX out ref of the UTXO I want to claim. And this is given in textual form with this hash in between, but Lucid uses something similar to the Haskell type we saw earlier in the lecture. So basically record type with two fields, transaction hash and output index. So I just split this string at the hash symbol and then extract the two parts, the transaction ID and the output index. Then I use the function we saw before to get all vesting UTXOs, and I just loop over them and check whether one of those has the correct reference. So I can compare the TX hash of the UTXO and the output index to the ones I'm looking for. If I find it, then I return it. Otherwise, I return null. This onVest function handles the button click of the vest button. So this is when I want to place a vesting. So this just extracts the beneficiary and the amount from the input fields in the HTML. Then I compose the datum that I want to use. So I must set beneficiary and deadline. Then in order to get the actual datum, I must convert this D to JSON, which I can do with another helper function from Lucid, data.to. We saw data.from earlier for the other direction, JSON to vesting datum, and this is the other way around. Given the vesting datum, I specify that and the schema I'm using, and out comes correctly formatted datum. Now I assemble my first transaction. So new transaction. And in this case, all I want to do is I want to make one payment. I want a transaction with one output, namely at the vesting script address with the amount I want to vest and the datum I just constructed. So I give the address, I specify the datum, and here there are these three ways that I have talked about several times now. Just include the hash and put the datum in the transaction, or use inline datum. So in this variant, I'm using inline datum. And finally, the amount. And I can just specify the Loveless. And then I complete. And that's all. Of course, the actual transaction will have also some inputs, because this money must come from somewhere from my wallet. And it will normally also have a change output, at least one, because I probably don't find the exact amount I need to place the vesting and pay for the fees in my wallet. So there will be some change. And that is something that Lucid takes care of automatically. So Lucid will automatically look in the UTXOs of my wallet to do so-called coin selection to find appropriate inputs, and also add change outputs when necessary that go back to my wallet. But I don't have to worry about that. All I have to do is specify that I want this particular output to the vesting script address. Then I use the sign and submit that I defined earlier to sign and submit, and just reset the input fields. This is the handler for the claim button. So I look up my own public key hash. I look up the reference from the input field that I want to claim. I use the function I explained earlier, find UTXO, given the reference. So if this reference indeed exists on the blockchain as a vesting UTXO, this UTXO will now contain that. And now I can construct my transaction, which is a little bit more complicated now than the other one where I place the vesting. So again, I start with new TX to create a new transaction. Now this collect from is basically the mirror image of pay to contract. So now I don't want to pay to a contract, I want to collect from a contract, namely this vesting reference here. So I give the UTXOs I want to collect. And remember, in this find UTXO function, we return an object that has two fields, the UTXO itself and the datum investing datum form So UTXO.UTXO is the actual UTXO. And this is the redeemer. I don't need to specify the datum because I'm using inline datum here. And if the output uses an inline datum, the input doesn't need to, again, provide the datum. So I don't need the datum, but I do need the redeemer. But for our vesting contract, the redeemer is just unit. And this is an expression for unit, one way to express unit. I think there is also an easier way to do this. Now I need to include the script, the actual vesting script in the transaction. I also explained that before, that normally the transaction that wants to spend from a script address has to include the actual scripts. However, it's now possible to also use so-called reference scripts, and we come to that later. But here I'm using the traditional way where I just include the script. So there's this attach spending validator, and I attach the vesting script to the transaction. Now I add a signer. So I have to explicitly say that I have to sign because the smart contract is expecting that. Remember, there were two conditions in the smart contract, that the beneficiary has signed and that the deadline has been reached. So in order to take care of the first condition, I must explicitly add this line here, add signer key, that I need to sign. We didn't have to do that here, even though we still have to sign here, because here we have to sign because the money must come from our wallet. In order to spend something from our wallet, we need to sign. But Lucid takes care of that automatically. But if signatures are checked in a smart contract, then in the transaction, one has to explicitly state that these signatures are needed. So that's why I need this line here. And furthermore, this is now where the time handling comes in. I must set a validity interval for this transaction, for this to work. If I didn't do anything here, then the validity interval by default would be the unbounded interval from the Genesis block to the end of eternity. And then Plutus validation would fail because then the Plutus validator wouldn't know whether the current time is after the deadline or not. So I must make sure that the validator sees that the current time is after the deadline. So here I use valid from, that corresponds to the Haskell from way to construct intervals. And I just use the deadline. So this says this transaction is valid from the deadline until eternity. Of course, if I try to construct this transaction before the deadline, then validation will fail, and it will fail before it ever reaches the Plutus validator. I explained that earlier, that before the validation scripts are run, it is checked that the current time actually falls into the validity interval. So earlier I demonstrated what happens if I try to claim before the deadline has been reached. So then this validity interval would be deadline to eternity, but the current time is still before the deadline. So the first validation step would fail because the current time doesn't fall into this interval. But if it does fall into this interval, which it does if I have waited for the deadline, then this first step of validation will pass, and then the Plutus validator will also be happy because it checks that the deadline has passed, and this guarantees that. And I complete the transaction, sign and submit. And I think that's basically it. So the rest is just UI stuff and hooking up the event handlers and so on, and polling the status periodically. So this shows how in not too many lines of code, a lot of them, of course, are also dedicated to UI things. I can set up a simple but functional DApp that interacts with the Cardano blockchain. And it also is serverless. I mean, it completely runs in the browser. It doesn't rely on any database or server. So you can just run it in your browser.